Welcome everyone. Thanks for joining us this afternoon for the first in a couple of webinars that we're going to run looking at energy use in horticulture and some sustainable options that maybe are on the horizon for us. We've got three, I suppose we're joined this afternoon by Barry Caslin, our energy specialist in Teagasc, and Eoin Sweetman, our specialized vegetable advisor. So thanks very much for joining us, Eoin and Barry.
Thanks, Dónall. Great to be here.
That's great. So I suppose we're all here because we've seen the price of energy going up and having an impact on our business. And I suppose that's really kicked off recently by the invasion of Ukraine. And while solar PV technology isn't new, it's probably maybe seeing a greater relevance with the increased cost of electricity. And I have to put my hands up and say I have solar panels on my home, and have been using them for the last 2 years. So I've kind of got a little bit of first-hand experience with them. So the schedule for today is Barry is going to give a presentation looking at some of the energy technology, well, particularly solar PV and batteries. And Eoin is going to cover, open up there with a poll, and he's going to cover our Q&A, and we might even have some growers with experience to join us as well if time permits. So that's the schedule. We've microphones turned off. You can drop your emails into the chat box. We're recording the session as well, and as default we have microphones turned off for the participants except for myself, Barry and Eoin. So we hope you get a lot of benefit out of it. Please drop in questions. We've had plenty of questions already, so it's really something of great interest to everyone. So it should be a good session. So I'm going to hand over to Eoin now to start with taking us through the poll.
Thanks, Dónall, and good afternoon, everybody. So I'm going to launch the poll here, and appreciate your participation in this. Afterwards, I'll share the results with everybody. So there's just 5 short questions just to gauge what people, the audience here, and what people are thinking. So the first question is, when is your peak electricity requirement? There's 4 options: winter, spring, summer, or autumn. The second question is, have you completed an energy audit of your business? Yes or no. Third question is, have you adopted energy saving technologies, for example, LED lighting? Yes or no. Fourth question, are you considering installing solar PV within the next 12 months? Yes, no, or not sure. And the fifth question is, on a scale of 1 to 5, rate the level of importance of taking action to mitigate the impact of energy costs on your business. 1, not at all important. 2, 3, 4, or 5 being very important. So just 5 short questions, and thanks very much everybody for your participation in this little poll, which just tees it all up nicely today. So I'll just give another another few seconds there just to fill in the answers. I can see them coming in there now.
Oh, and while you're going through that, I suppose, as advisors, we've traveled around and we're seeing a lot more of this technology in use. In some sectors, it's well established. In some others, it's just coming in. So we can see that there really reflected in the poll as well.
Yeah. Okay, so just another couple of seconds there. I can see most people now have voted. So we'll call it a day there now. End poll. Okay, and now I'm going to share the results, so they'll pop up on your screen. I'll just very quickly go through these. So when is your peak electricity requirement? Almost 50-50 there for winter and summer. Some just 1 or 2 probably in spring and autumn. Second question, have you completed an energy audit of your business? Actually, to me anyway, a surprising amount, yes, which is great. That's a great start. 60% have said yes. 40% still could take that step. The third question, have you adopted energy saving technologies such as LED lighting? And great to see 83% have said yes. So that's brilliant. Everyone's taking steps towards these technologies. Fourth question, are you considering installing solar PV within the next 12 months? And again, a lot of interest, 60% saying yes, only 10% saying no. And about 31% there on the fence, still not sure. And then on a scale of 1 to 5, really no surprise here. 90% saying it's very important, with only the other 10% saying it's important. So everyone recognizes the importance of this topic today and is interested in solar PV. So thanks very much for your participation there. Stop sharing that, and I'll hand you back to Dónall now to introduce our speaker.
Yeah, Eoin, thanks very much. Really interesting insight there to the audience joining us today. So I'm going to hand over to Barry now, who's going to run through some of the solar PV technology. And Barry's he's got years and years of experience in energy use in different aspects of horticulture and agriculture. And today we'll look just at PV and batteries. We will come back in a couple of weeks and look at some of the other technology, but I'm going to hand over to Barry now, and we'll do a bit of a deep dive into some of the issues there. Okay, so Barry, thanks very much.
Thanks, Dónall. Yeah, we'll cover the solar PV today. As far as I understand it, we're going to be covering the likes of biomass and other technologies and wind on different occasions, and on Mondays. Next Monday is a bank holiday, so it'll be the following Monday that we're coming back at this again. But yeah, very topical subject, and very interested in the poll there as well that Eoin conducted. The whole area of energy audits. I think it's so important, because what you can't measure, you can't monitor. I think an energy audit really tells the story as regards what your energy use on your farm is, or on your unit is. You can do small little micro monitoring of different pieces of equipment on your farm, from refrigerators to lighting, just to see where the energy is actually being used, and the audit will tell you all of that. And just that everyone is aware of it as well, it is possible to get a grant. It's in the region of around €2,000 from SEAI to do those energy audits on your farms. If you're a registered company, you're entitled to that grant aid, and it generally covers the cost of the audit. So it's well worthwhile doing. So I'm going to share my screen there now, Dónall, and
yep, that's great. Thanks.
I'll just go through a presentation here. Is that sharing okay now?
Yeah, I can see that perfectly. Thank you.
Okay. So good afternoon, everyone. And I'll go through this about solar PV in agriculture and the opportunities that are there as well, and a bit about the technologies. Maybe I know it can be quite confusing for many people, because this is a technology we're hearing a lot about, and you're just wondering, how suitable is it for my business? Like, you will need roof space, and in some situations maybe you're concerned about you've only glass house space, or you mightn't have the space around you to do it. So that can be they can be the limiting factors that can determine whether PV is going to suit a horticultural system or not, or a mushroom system. So just in terms of solar PV itself, or the technology, what it's doing, it's converting energy from the daylight and the sun into electricity. So it is an intermittent technology. It's not producing electricity at nighttime. It's only producing it during daylight hours. And contrary to what a lot of people might believe, it is actually generating electricity even on cloudy days, but albeit not as much as it would be on a bright sunny day. So it's a well-proven technology. The technology has improved so much over the last 10, 15 years in terms of converting that daylight into electricity. It's now government policy to electrify heating. So we will see a lot of our homes being heated by heat pumps. Now, those heat pumps will run on compressors, and those compressors will require electricity. So really, heat pumps require electricity to heat your house. And of course, we're seeing the whole electrification of our transport as well, through electric cars, which will require batteries to be charged using electricity. Ideally, that will be electricity coming from your solar PV on your farm or your unit. And of course, electricity prices are trending upwards. So, this time last year, we were talking about maybe 20-25 cents a kilowatt hour for electricity. Now we're going up to 35, 40, over 45 cents in some situations per kilowatt hour for electricity. Night rates have gone up as well. So it's important to take that into consideration as well when deciding on solar PV. So as I say, it does work well in Irish conditions as well. It is possible to predict the kilowatt peak of installed capacity. So if you put up 1 kilowatt of solar PV, generally it runs for, the way you calculate it is you multiply 1 by 8,760, which is the hours in the year, and then you multiply that by a figure of around 10% efficiency. That's 10% of that year you will be generating kilowatt hours of electricity. So 1 kilowatt of solar PV might produce anywhere between 700 kilowatt hours, maybe up to 1,000 kilowatt hours of electricity if you on a very good day in the right location. Panels should face south or east-west in orientation, so it's important to get the compass out there and make sure that they are going on the right roofs. It's important that you don't put them on a north-facing roof unless it's a flat roof that will capture the sun. It is possible to remotely monitor these solar panels. So on your mobile phone, you'll be able to see what you're generating at a given time of the day. So it does generate electricity in what we call a bell-shaped curve when you look at it as a graph. So when you look at it from February to November, it's going gradually up, and when you hit your summer months of June, July, and August, it's going up, and then it comes back down again as we progress towards November. So it's that bell-shaped curve of production. So you do have to look at, I suppose, when you need the electricity, and does the solar PV match with your demand for electricity as well. I know we are going to cover wind on a different day, so maybe wind is something that might suit in certain situations, but solar, again, just like wind, is an intermittent technology. It generates the energy or the electricity when the sun is shining. It's important to size that the output is less than the base load of the farm. So there's no point in oversizing these units because you won't be able to export any excess electricity back to the grid if your unit is over a certain size. So that'll be important to get it right in that regard. I suppose in terms of solar PV panels, they're a very robust technology with no moving parts. They do have an expected lifetime of maybe 40, 50 years. You will have what's called performance efficiency losses, and this is something you'll be asking your installer, what's the expected performance efficiency losses I can expect with this technology or panel that you're trying to sell me? There's no routine maintenance. There's some occasional cleaning required. You know, in Ireland, we don't get as much dust, so we get natural cleaning by rainwater, keeping them clean. Some countries like Spain or Italy, they might have a lot more dust, and they do require more cleaning. Otherwise, the efficiency goes down if they're not cleaned. The inverters and the control gear, that would have to be replaced every 10 years or so. So again, how much is an inverter? So the inverter is essentially the piece of kit that converts the direct current into alternating current, which we require in our buildings and in our homes. We need it in AC form. So that's what the job of the inverter. That piece of equipment will have to be replaced. It won't last the lifetime of the panels itself. So you do have to factor that into your payback period. Inverters could be maybe 7 to maybe 10 or 12,000 euro, depending on the size of the inverter that will be required. The buildings need to be strong enough to take the weight of it, and I think that's important as well, that if you are going to put them on a building in your yard, is it structurally sound to take it? If a fall of snow came, would it be able to take the weight of it as well? So they're the things that you need to take into consideration. Glass houses may be suitable if it's placed over storage areas or on corridors. The electricity generated can be consumed on site with the remainder exported. So it is possible, if you're under 50 kilowatts, for example, in microgeneration territory, that you can start exporting excess electricity back to the grid. A detailed energy audit, which we spoke about earlier on, that's going to show you the savings that you can make from the home generated power, and decide then on the scale of your solar panels, because each kilowatt is going to cost you maybe anywhere from 900 euro to maybe 12, 13, 1400 euro, maybe at a smaller scale. So you do get economies of scale. The bigger that you go for, it comes in at a lower cost per kilowatt installed, whereas you went for a small domestic type system, will obviously come in at a higher cost. I suppose it's just good to discuss this in the context of, you know, the potential energy use on these on the different farms. And I just put this down, and this isn't to say that this is what your farm is doing or achieving, but just mushrooms. I just looked at the typical energy use that was used on mushrooms a number of years ago, where, you know, in terms of sterilization, again, you'd be using a lot of biomass in the area. I should have that in the top in terms of the energy technology. Biomass, oil, gas boilers, they would have been traditionally used. Now you're getting a lot more biomass in those areas, but a lot of the energy on a mushroom unit would be for heating of the growing room and sterilization. So you can see the majority of those 3,945 kilowatt hours of typical will be on heat. Whereas if you move down to the electricity there in the third column across there, where you have 100% electricity, would be for the cooling of the growing rooms, ventilation, crop chilling. In some cases, if you are compost prepping or packaging, packing there, you know, there would be a certain amount of electricity used there as well. But the majority will be used in the cooling of the growing rooms for most growers. 845 kilowatts, and maybe in a best practice scenario, maybe down to 520 kilowatt hours per ton of mushrooms produced. So it's just that there are some units probably more efficient than others, and you know, by putting in the best practice guidelines, you know, that's how you can achieve those better figures. But that's where the electricity will be used, maybe to use for the from the solar PV. On glass houses, potentially, you know, you have a certain amount of heating where biomass boilers could be the technology of choice. But again, there's a certain amount of refrigeration, lighting, and general machinery, motive power, pumping that will be required. But the vast majority, again, is for heating. And you have best practice scenarios and you have average scenarios. So in terms of, you know, the sizing of these is very, very important. So, and most people will be asking the question, how do I size a solar PV unit? So, you know, a domestic dwelling house there, if you take the lower one first, you know, you would see typical situations where a 5 kilowatt peak system on a domestic dwelling house might meet 70% of the home's requirements. Now, and of course, that all depends. Am I going to be in the house during the daytime? Am I working from home? If I am, I'm going to be using more of that electricity myself. If I might have to divert surplus electricity during the daytime to heat the immersion tank. So you can put a diverter on. It might cost about an extra 700 euros, but you can divert the electricity to heat the hot water, and that's like a form of battery storage in its own right. And then the balance goes to batteries during the day, and maybe with discharge, which discharge at night. There's an example there in the Midlands of a 100 kilowatt photovoltaic system on a pig unit, which is producing 93,000 kilowatt hours of daytime electricity per year. And all of that energy is used on the farm. So you can see there, you know, you could potentially on a pig farm or a poultry farm be using 200 kilowatts, maybe 300 kilowatts of base load. It might meet that continuous requirement on the farm, and they wouldn't need to export any of those kilowatt hours of electricity. So that system there is generating 20% of that farm's annual requirement. So the paybacks to date, the only viable option has been to follow the self-consumption or the microgeneration route. So where you can actually offset a kilowatt hour that you would otherwise have to import. That's the best scenario. I suppose this time last year we were talking about, you know, if you were exporting electricity to the grid, the wholesale price or the market price of electricity was just around 5 cents per kilowatt hour. And it's amazing the change that's occurred in the last few months, where we see now prices of around 20 cents per kilowatt hour being offered for any excess electricity. So that means that if you're with Pinergy or Electric Ireland or with SSE Electricity or Bord Gáis, some of those electricity utility suppliers, you can go back to them and say, what would you give me for any excess electricity I give you back? And, you know, it's a bit like switching. You know, switching from year to year, you can do that. You can switch from one provider to the next, and you can switch by the sweetener, and it may be that they'll buy back the electricity from you at a fairly keen rate as well. Assuming the size system will supply 30% of the farm's electricity need, or sorry, a typical solar PV installation for an 11 kilowatt system would cost in the region around 15,300 euro. So if you assume that the size system will supply 30% of the farm's electricity need, it's going to pay back for itself in about 7 years at current electricity prices and without grant aid. And that system will offset 3 tons of CO2 per annum. So I suppose this could be something that may be important in your own business in the future as well, where the CO2 abatement or the tons of CO2 that you're offsetting by having your own electricity provided, it may be helpful and maybe getting a contract with a supermarket where you're able to say that you're generating your own electricity. The green credentials, I think, will become more important in the future. I think it's important to size the system so that the electricity is used on the home or the business itself. It may be necessary to divert surplus electricity towards heating the hot water As I mentioned, they're an accumulator tank or an immersion type tank, and maybe a battery storage, or maybe using your electric vehicle. I think in the next 10 years, in 5 to 10 years, we will see a lot more electric vehicles around. We'll see a lot of equipment on your farms, ATVs, that could be charged, using the surplus electricity that's been generated to your PV panels. So you could be charging farm vehicles as well. So just in relation to panels, when you're being approached by a sales agent, they're generally, they are 1.66 meters. These modules are called 1.66 meters by 1 meter. And they could be anywhere between 280 watts per panel. And now they have come up to about 400 watts per panel, which has surprised me in recent weeks. I've only heard this, that they're up to 400 watts, like it was around 320, 330, but now I'm hearing 400 watts per panel. So that's 0.4 of a kilowatt, essentially, per panel. The design of them, it's a glass foil design. So there's cells between a pane of glass and a foil laminate underneath. Generally for, poultry units, pig units, where you have a lot of ammonia being generated, you would need glass on glass, and you need a more robust type panel, because the ammonia gases or the salt erosion that you might have in sea coastal areas might be an issue, and that's where you need the more robust type glass on glass panel. So it's a question that you'd ask your supplier. I'm in a coastal area, or I have ammonia gases potentially coming from pig or poultry or something, or that in that situation you may need to go for a more expensive type of panel with glass on glass. And then, the two questions you ask as well is, what is the performance warranty and what is the product warranty? Generally, product warranties are anywhere maybe 10 years, and the performance warranty can be guaranteed maybe at 25 years. So, so the product warranty is essentially the warranty on the solar panel itself. The performance warranty is how well will that perform over a period of time, and for how many years will it be giving me those kilowatt hours. And generally you will get degradation. You will get degradation maybe at 0.5%, maybe up to 0.7%. Maybe some suppliers might say it could be even higher than that. But it's just an important question to ask. What is the expected degradation rate of those panels that you're selling me? And so that means if your 1 kilowatt of PV was going to produce 900 kilowatt hours of electricity per year, that could drop down by 0.7% per year on year, because of I suppose just wear within the system itself. Some restrictions: the average size farm where the house and the farm is run on the same meter should consider a 6 kilowatt single phase or 11 kilowatt 3-phase. So this means that you don't have any connection issues with ESB networks if you're looking for a system of 6 kilowatts at single phase or 11 kilowatts at 3-phase. There's you don't need any ESB approval for that. You do have to let them know that you're connecting to the system, all right, but there won't be any issue with it. It's where you're going above that is where you have to start looking for ESB approval. So for homes, the ideal system size is between 3 kilowatt peak to 5 kilowatt peak. You could see some domestic situations, maybe 6 kilowatts as well, but generally it's somewhere between 3 and 5 kilowatts. And so the average house per year, domestic, to put it in that context, the average domestic dwelling house might use between around 4,500 kilowatt hours of electricity per year. So a 5 kilowatt peak system would probably produce maybe 4,000 kilowatt hours, maybe 4,200 kilowatt hours per year. So that'll depend on if you're up in Donegal or if you're down in the southeast of the country. Obviously in the southeast, you're going to be getting more kilowatt hours of electricity down there from those kilowatts installed. So this, without having, so if you did want to go above this, for larger systems, what you're talking about putting in this thing called a G10 protection relay, and that stops electricity going to the grid in the case of an emergency, but it can add a very significant cost. So if you want to go for a bigger system, but you want to protect against, say a 200 kilowatt system, and you want to protect against any excess electricity going back to the grid, you would put in this thing called a G10 relay, and that would add a significant cost. Maybe it could be 4,000 or 5,000 euro that you're adding to the cost of the application. The planning limits that were there of 12 square meters for domestic and 50 square meters for agriculture are now removed. So 50 square meters, what that means is it's about 300, it's 50 square meters would have been generally around 9 kilowatts of solar PV, but that's changed now that you can actually go up to 300 meters squared. So that will cover you for 50 kilowatts of solar PV. So the planning was eased in the last couple of weeks in relation to that. So that should be a big plus and big benefit, because it was adding a cost onto systems where you had to go for planning around solar PV. So supports and costs that are there as well. So what is the cost of installing solar? So it can be anywhere between 900 euro per kilowatt installed, up to maybe 1,800 euro per kilowatt peak installed. And that would be for a smaller domestic type system. So obviously you do get economies of scale. So if you go for a larger system and where the installers can get on site and get more kilowatts installed, that reduces your costs as well. So the payback is normally between 5 to 7 years. That depends on energy prices, depends on the grant secured, and the cost of the system itself. Battery storage can be anywhere between 700 euro to 1,400 euro per kilowatt hour. But that's only recommended if you cannot use the daytime electricity. I suppose the fact that you can export excess electricity back to the grid now really makes batteries less, I suppose, less likely to be required on farms. But there may be some situations where battery storage may suit as well, because they can store that excess electricity that's being produced during the day if you can't use it, and if you have, you can discharge it at night time. Farmers are eligible for TAMS grant of 40%. And there's the horticultural grant scheme that's available at 40% as well. I have a slide on that later on. But if you do get a TAMS grant or a horticultural grant, the problem at the moment is that you can't sell the excess electricity back to the grid, which is a bit of an issue at the moment. Currently, farmers can get a 30% grant through the BEC. That's the Better Energy Communities run by SEAI. And I suppose, and what I'm hearing is you can actually sell excess electricity back if you get a BEC grant. Renewable energy projects on farms qualify for 100% accelerated capital allowances. So I think this is an important point here at the bottom, the bottom point here, because who knows how long this is going to be available for. And the fact that you can write it off in one tax year can be very, very beneficial, maybe if you're facing fairly high tax bill at the end of a given year, that you can write it off in that year. So it's something well worth considering. In terms of the export potential, there's the option there for putting solar PV on the roof space of farm buildings. And of course, the microgeneration support scheme, which is available now at the moment. Well, you can export at micro scale back to the grid now at the moment. I'll show you the tariffs for that in the next couple of slides. But a lot of people, I suppose, get mixed up between microgeneration. So microgeneration is up to 50 kilowatts. The larger scale systems are above 500 kilowatts, and they're supported by what's called the RES, R-E-S-S, the Renewable Electricity Support Scheme. And what the RES is it's an auction-based system, and it actually you'll be hearing about, thousands of hectares of land covered in solar PV panels. You're going to hear about that's supported through RES, offshore wind, onshore wind, those large turbines that will be going into the sea, that will be going onshore as well in the country. They will all be supported through this RES scheme. So they're projects greater than 500 kilowatts. There's nothing actually in between the 50 kilowatts of microgeneration and the 500 kilowatts. So I know the department are working at the moment on what's called a small scale generation scheme that will cover that area between 50 kilowatts and 500 kilowatts. And I think community schemes will be coming into that area also in the future. But just that you're aware of that there will be something there to take that space, hopefully early next year. Just in relation to the microgeneration, I think it was around, well, it was close enough to this time last year that this graph was published by the department, and they stuck with it. And they came up with for systems there. If you look at the extreme right there in 2022, there was to be a clean export premium tariff fixed for 15 years of 13.5 cents per kilowatt hour. And that will go down. So you'd be locked in at 13.5 cents for 15 years if you got the panels up in 2022. This actually scheme hasn't kicked in yet, but you can see there, if you put them in 23, you can still avail of this 13.5 cents, and 24, then you're down to 12.5 cents, and it goes down 1 cent per kilowatt hour each year then after that. So I suppose that's an incentive to get people moving earlier rather than leaving it later. That's for between 6 kilowatts and 50 kilowatt systems. That is that has not kicked in yet. That clean export premium, or CEP as it's abbreviated, that is not available to, and that's only available to businesses. So that's not for your domestic dwelling house. For your domestic dwelling house, on the extreme left hand side there, you can see there it's less than 6 kilowatts. You can get a grant of €2,400 for those years, 2022, 2023. That's for a system of up to 6 kilowatts. And you can also, on your domestic dwelling house, you can also get what's called the Clean Export Guarantee, or that's the competitive market rate of electricity. So you can do this today. You can go to Electric Ireland, and if you put up your PV panels in your house, you can sell the excess electricity back to the grid. If you're with Electric Ireland, you can ask them, what rate can you offer me, and knock it off my bill, or whatever way that they're going to pay you for any excess electricity that I produce through my solar panels during the day when I can't consume that electricity myself. So that means that negates the requirement to have a battery storage on your house or on your farm as well. So then it is possible also in your businesses, because I mentioned that you can't get the clean export premium on your business there at the moment, but what you can get is the clean export guarantee. So you can, similar to your domestic dwelling house, sell the excess electricity for your business, and you can go over 6 kilowatts for this. So you could be up to 50 kilowatts, and you can get, sell any excess electricity back to your supplier. So that is available. The funny thing that's happened here is that, we thought this rate of 13.5 cents was good this time last year when it was being, when it was being talked about, but the competitive market rate this time last year was around 5, maybe 6 cents per kilowatt hour. Well, now what's happened is that the competitive market rate has gone above the clean export premium rate. So now you can get 20 cents per kilowatt hour from the market. So maybe that's the reason why this CEP, or clean export premium, hasn't kicked in yet, because most people are playing the markets and they're able to sell excess electricity back through their supplier and get the market rate. But the thing is, you can't get both. You can only get one or the other. And it's still unclear as regards, do you opt for one first, or do you have to, as far as I know, you can't switch from one to the other once you're getting the market rate. But I think once you're getting the premium, you have to stick with the premium, and that there's a few gray areas there in relation to that. But at the moment, you can certainly get the market rate for your electricity, and which is around 20 cents per kilowatt hour, and export it back to the grid. The Department of Agriculture, Food and Marine have the Capital Investment Grant Support Scheme for horticulture, which provides 40% support for capital investments, including sustainability options, and which includes energy, and there's 50% support there for those under 35 years of age. Support for all the necessary equipment, including inverters, labour. There's an assumption that the support covered the adequate production for your own use only, so not for export. Those applications are soon going to be open, and they're going to close in mid-December, and the offers will be made from March. So I suppose for anybody considering this scheme, you will be talking about waiting until next March before you get your green light or go ahead to get your panels, and the payment then is made after the inspection. So the energy generated can only be used in the business, and there's a separate, should be a separate fuse or MPRN for the home and the business, so that they shouldn't be on the same MPRN, or else a deduction has to be made if they are on the same MPRN. And for those of you that can avail of TAM support, and I suppose the TAM support reference costs are, and I think they're the same as what will be used for the horticultural scheme, because it's all provided by the Department of Agriculture. So the reference cost within TAMs for solar is each kilowatt is supported at €1,253 per kilowatt, plus a €1,608 sum there for the installation. So if you, the maximum grant for a dairy farm, for example, would be 11 kilowatts so 11 at 3-phase. So an 11 kilowatt PV system in TAMS would be 11 by 1253, which is 15,391. So if you take 40% of that, that's €6,156. For rechargeable batteries, you can only get in TAMS, you can only get 6 kilowatt hours support. So that's which is a bit on the low side. It could do it being actually much higher than that. But that's what the way it is at the moment, 6 kilowatt hours. So 6 by 703 is 4,971 euro, and 40% of that, which is the grant you will get, will be almost 2,000 euro of a grant there, 1,988 euro 40 cent. So so they're the supports available under TAMS. I don't know about those reference costs. I think they're fairly well still in line, but the department do change those from time to time based on as technology costs increase. They do change those reference costs as well. For pig and poultry, they have a higher grant, and there is a 90,000 euro ceiling built in here as well. That this is a separate grant from sheds and other types of works that will be going on the farm. In the past, it was all pooled together. So if you're getting a TAMS grant, for your shed, you could have all your TAMS money mopped up because it was an 80,000 euro ceiling, and 40% of that was your upper spend on TAMS over the Rural Development Programme period. So a lot of people had their TAMS all used up by the end, within maybe 2 or 3 years into the Rural Development Programme period of up to 2022. So this is and they're not in a position to go down to apply for the new TAMS until the beginning of January. So that's the new clean sheet essentially, and we're into a new Rural Development Programme period from the 1st of January of 2023. So there will be people ready to get going again, hit the ground running, and I suppose looking at sizing their system and making an application in the new TAMS potentially in the new year. But I suppose the good thing about the new TAMS in 2023 is that there'll be a separate pot from shed buildings, tanks, static tanks, all that kind of stuff, to the solar stuff. That'll be the energy efficiency stuff will be put into a separate pot, so you won't be able to you won't be robbing your energy efficiency sustainability pot by building a shed or putting in a tank or something like that. So just in terms of battery storage, there's lots of different brands out there. Batteries can operate in both alternating current or direct current. So batteries can discharge direct current by surplus solar during the day, and once discharged, it can be recharged on the cheaper night rate electricity for discharge in the morning. Batteries can act as a power backup as well. So I suppose battery storage, it allows surplus energy generated by solar panels to be stored for later use. It allows you to maximize your self-generated electricity. It needs to be proactive role there in the future energy systems and reduce the carbon emissions. It allows you to be off-grid or as energy self-sufficient as possible. There's a need to assess your annual farm or your household electricity usage and generation capacity of your solar panels as well. So this is where you, I suppose, match how much battery storage you'll require in terms of kilowatt hour of battery storage based on your generation capacity and your household electricity usage, your farm electricity usage, wherever it's going to be demanded. And then after that, you're going to consider the likely installation costs based on the type of battery you want. So there are different types of batteries. As you have your lithium-ion battery, so a lot of household appliances would have lithium-ion batteries, like your mobile phone runs on lithium-ion. Most car batteries nowadays, they're lithium-ion for the electric cars. Or else you have your lead-acid batteries. So your lead-acid batteries, they tend to be used off-grid. They're bigger, they occupy more space, are they've a lower energy density per kilowatt hour per kilogram. And of course, the lithium ion are more expensive than the lead acid. So there's pros and cons to each of those batteries. But generally, the lead acid will be used for bigger type projects. The usable capacity of a battery, this is a question that you may be asking a battery supplier of the capacity. Generally, the capacity is how much electricity that the battery can store in kilowatt hours. So a unit of electricity is a kilowatt hour. So the usable capacity is less than the total capacity, and this is more a safety that batteries should not be discharged completely. So it's a safety component of batteries. So a 14 kilowatt hour battery that might have a usable capacity of 13.5 kilowatt hours, so you wouldn't get the full 14. Another thing that people should be aware of as well is charge cycles. So this is just to be aware of it as well, that one cycle is a full charge and a full discharge, which is very, very rare. So if you compare that to your mobile phone, do you charge it when it's down at 0% and then fully charge it? It doesn't very often happen. So people might charge it when it's even at 50% and allow it to charge up to the full again. So batteries usually partially charged. So a 50% charge and discharge is called a half cycle. And these batteries are warranted in terms of the number of cycles that you get out of them in years. So you can, if you know the warranted cycles, you can work out how many kilowatt hours that the battery is going to give you over its lifetime. So if the battery is warranted for 10,000 cycles, a 12-hour kilowatt battery should give you 120,000 kilowatt hours of stored electricity from the battery. Batteries do degrade over time, so that you do get what's called a performance warranty as well. So you're going to get fewer kilowatt hours per cycle. And it's a bit like your phone, you know, the performance of it does go down over time as well. The current batteries have cycles warranted from 6,000 cycles to 10,000 cycles. So this is different to a product warranty. This is a performance warranty. So these are questions that you can ask. You'll be asking about a product warranty or a performance warranty in relation to your solar PV panels. And you'll also be doing the same in relation to your batteries. So, and also the charge and discharge rate. So this is the power input and the output in kilowatts. So you have to ensure that you have enough power output to run the appliance. So if you take, for example, a 5 kilowatt hour output, that could run a kettle, it could run a tumble dryer, it could run an electric fire, but a 2 kilowatt output probably won't do that and won't be able to do that. So if you can't if you can't access enough stored power when you need it, you're going to get what's called this bottleneck effect. And that's where grid electricity is going to be required to supplement the difference required. If you can generate 4 kilowatts and your battery can only take 2.5 kilowatts, then you're wasting 1.5 kilowatts of power. I just, in relation to batteries, it's important to say that some batteries do not provide backup if the power is out, and if it's essential that to do that, you may require some rewiring, and you may need a larger storage capacity to allow for that as well. So some people ask the question about AC, alternating current, or direct current coupling. That's coupling with the batteries. So solar PV, that needs what's called an inverter. So that converts the direct current to alternating current, which we need because AC or alternating current is the most common way to send electricity around the grid in Ireland and most of the world. So a system using DC coupling has a single combined inverter. So a system with AC coupling, that requires separate inverters for batteries and panels. So I would say to you in this area, it's important to speak to your installer about this, because they can solar PV or the batteries can work in both AC and DC, as I mentioned there already. So just finally to conclude, there's opportunities here for development on farms is great. There's roof space, and in some cases you may have ground-mounted space. Granted, maybe in horticultural systems, the space might be more limited unless you have maybe outhouses or offices where they can go on. It's not going to suit all greenhouses or glass houses. Solar causes no emissions to the air, soil or water, which can be good, I suppose, from a food growing perspective. Solar PV can meet on-site electricity needs for heating, pumping, ventilation, and process energy. The electricity prices have continuously fluctuated in recent months, and an increase in electricity prices in the coming years is likely. Ireland will see an increased shift towards farm use of solar energy. And of course, don't forget there will be more carbon taxes as well. If the problem in the Ukraine goes away, we are going to see carbon taxes. So we are being driven towards renewable technologies by other policies that's going to drive us this way anyway. Battery storage is a rapidly evolving technology, and it's an area that we really need to keep an eye on, and it can suit certain situations. I'll leave it at that there, Dónall.
Barry, thanks very much. And your contact details are there at the end as well if people are interested in following up with you. You've a lot of details on the Teagasc website as well. You've covered a lot of this topic in maybe even more detail there. So it's great to have that to go back to. Huge amount of information covered there, Barry. So and plenty of questions coming in too. Before we go to that, I just want to see, we might have one participant there who we're going to bring on because they have some experience. So maybe just we'll see how this goes. Hello, Con. I'm not sure if you're able to hear us there or if you're able to join us. No problem, Con. Thanks a million for joining us. I'll just introduce Con to the participants here. Con has an orchard in Clonmel and has been there. He's second generation with the orchard there. He has a kind of a diverse site with an orchard, fruit farm, and also a campsite. And he's a lot of experience. He started with evacuated tubes for heating hot water there about 10 or 12 years ago, and is on to solar power now. And if some of you follow Con on Twitter, you might see his energy outputs during the summer. It has been interesting to watch. Con, so thanks a million for joining us. Maybe Con, could you explain a little bit more about your setup and maybe some of your experiences there? And you can be brief there because I know we've caught you at short notice.
Grant, I'll be very brief. I'll leave it on sound only for the moment, Barry, if that's okay.
No problem. Thanks, Con.
I should say. Basically, I suppose we started monitoring electricity quite a while ago, but we started monitoring with a view to putting in solar panels in 2014, and that was just to get an idea of our base load. So we had, these clip-on monitors on various sheds, stuff like that, or the power going to various sheds, things like that. And when we aggregated all those power uses, in the daytime, our base load is around 20 kilowatts, and at nighttime it's around 9 kilowatts. So on that basis, we kind of started looking at what kind of solar setup for electricity would suit us. And in 2017, we made an application to the horticulture scheme, and we put it in 2018. So we put in a 50 kilowatt, two sheds, roofs basically, each on a 25 or actually 30 kilowatt inverter. They do occasionally combine to produce about 50 kilowatts, although obviously most of the time it's less than that. We modeled it at the time before we put it in based on the base load and how many Sunday mornings we might be using much equipment and that kind of thing. And it was going to produce about 15% of our electricity, and there was going to be a very small leakage back, maybe 1 or 2% of the power was going to go back to the grid without getting paid for, because getting paid for it wasn't really enough at the time. So that's been running fairly, without intervention ever since. The initial idea, I suppose, that or kind of look at it was that the payback would be 7 to 8 years. Now that the price of electricity gone up, obviously that shortened a lot. Although I think we probably got fairly good value in panels that they install at the time, with so many people looking for panels to install. It hasn't really got cheaper in the interim. So yeah, we were very, very happy with the setup. It's done as it's, as we expected. Tipperary Energy Agency did actually apply for us for an SEA grant maybe in 2017 for that. But we were unsuccessful with that. But some of the modelling that they had done was useful afterwards, because we had to confirm the kind of more basic models that we'd done on, what the output would be and how much more power that would use. I did have a little slide that I made up on my computer, but my computer won't connect to Zoom at the moment. But I could email it to you maybe if you want. It kind of shows what we did, that kind of thing. So that I suppose those are the main points with it.
Con, thanks very much. You've done quite a lot then over kind of a reasonably short period of time. There was a long lead in time and a lot of homework done to kind of bring you down a certain route into picking what you have. And I guess from Barry's slides as well, it looks very much like there is no one size fits all, and that you do need to start some level of auditing and monitoring. Do you think it delivers everything you expected, or is it even better?
Yeah, because I had the hot water panels previously, because we use quite a lot of processed water for washing bottles and stuff like that, energy separation. And they required a fair bit of maintenance, that kind of thing. But this is literally, we haven't looked at it apart from just checking that it's still working ever since. Been no servicing, nothing like that. They were good panels. I think they were a Norwegian panel that went in there. It's a good SMA inverters. I think they're pretty much the best inverters you can get. I did hear Barry talking about that unit that has to go between the inverter and DSP to make sure that you don't accidentally electrocute people if the power goes off, as in electric DSP workers or whatever. That's built into those SMA units, but the ESP still want another safety device built in, so we did have to put in the extra ones. But it is kind of overkill, all right. That's needed twice, but they weren't as expensive as Barry had mentioned in the presentation.
Con, I really appreciate your insight there and sharing that information. I'm going to hand over to Eoin next, and he's going to introduce another grower. So thanks again, Con. And I know, as I mentioned, Con is on Twitter, and there's always some nice insights coming from your Twitter feed. So thanks again, and thanks for joining us. And I'll hand over to Eoin now.
Thanks, Con. That was very useful. And Dónall and Barry, thanks for the presentation. I'm going to bring in now Paul Brophy. So he should be able to come in here shortly. Paul is a large-scale broccoli grower in Kildare. And Paul here's Paul now. You're just sideways, Paul, there on us.
Okay.
Don't worry, perfect. That's a great job. Thank you very much, Paul, for joining us here today. Paul is just going to give us Paul did an energy audit, and he's just going to give us a brief overview of how that process was for him and the benefit that it was for you, Paul. Thanks.
Okay, can you hear me there now?
Loud and clear, Paul. Yeah. Okay.
Yeah, I suppose. Well, I got the audit done originally. It was more for, we were looking at solar PV, and I felt from some of the people I'd spoken to in the solar PV, they were overselling to me what I needed, and I knew nothing about it. So I brought in a consultant to do that. But before he sat down with me to do that, he said, you realistically need to do something on your own housekeeping first. And it was an outside set of eyes coming in, and I suppose we all don't like to be self-critical of our own process, but it was excellent. I mean, he pointed out such simple wins for us, like putting timers on the air compressor. I mean, we've air compressors there to run some of the packing lines. It would have been left on year in, year out, and we'd only be packing for maybe 5 months of the year. And there'd be small air leaks here and there, and the compressors would be kicking in. And you'd have to view that as diesel leaking, because it's energy leaking and it was costing. Simple, very, very low fix, a light outside a closed building like a fridge to indicate that the lights are on inside, to remind people to turn them off so they don't have to open the doors to check them out. And I suppose the big win for us was on the refrigeration. We would have been for anyone who doesn't know how the way it works with broccoli is you harvest early in the morning to sort of mid noon time. You bring it back in, you blast chill it, and you try to get that temperature out of the product from whatever the field heat is on the day. If it's a very warm summer's day, it could be 25 degrees, down to about 2-3 degrees as quick as possible. Now it takes about 12 hours for the batches we bring in for us to do it. So our fridges would be, our blast chiller would be running absolutely flat out from lunchtime until probably midnight. And we didn't notice it, but in our ESB bill, we were breaking our MIC, our maximum import capacity, and we were being charged for this every 2 months. And it was a considerable amount of money for the 5 or 6 months of the broccoli season. And literally by just putting a timer on the other 2 fridges, we have 3 fridges, a blast chiller, a stock fridge, and a goods out, and making sure that every half an hour, one of the other fridges wasn't in cooling mode during that peak period, we saved thousands of euro in the first winter, spring and summer of doing that. I know that the bills were significantly down, and it was just, we had just completed it at the time of everything, you know, starting to take off and go mad in price. So we got full bang for our buck. Now, if somebody asked me how much did the consultant cost, I can't really answer that because he was doing the other project as well, and it was all rolled into one. But I'm sure, you know, you'd get SEAI funding on that. But he pointed out so many little things, like there's a Burco boiler in the canteen, constantly boiling. At weekends, at, you know, stuff that was under your nose, but nobody was picking up on it. And, you know, very, very simple, quick wins. And that wasn't getting into the simple investment stuff like the LED lights in some of the fridges, which were put in for a grant to change out. But some of them were involved with spending very little money to get a huge return back. And it just brought an awareness into the business that everybody was much more aware when we sat down with this guy. And I think that's a big thing too, is just staff awareness. So that's quick.
Listen, Paul, that's brilliant. Thanks very much. And you know, you're really highlighting the benefit. I think it's a great first step for any grower to do. And just to reiterate the point, I think it came up in the poll at the start of the webinar, and Barry mentioned it again, that there is a €2,000 voucher there that small and medium enterprises can get from SEAI for a professional consultant to do that energy audit. So it's a great first step. So thanks very much, Paul, for joining us today and giving that insight.
Okay, thank you.
Thank you.
Thanks, Paul and Con. I'm going to let you, if you'd like to stay online, that'd be great. I'm going to hand over to Barry now, and well, Eoin and Barry maybe do some of the question and answers session. And I think even just a comment there, a quick one came in from Con saying it's an excellent point from Paul Brophy there. Tiny leaks in my air systems coming from the compressor were costing €2,400 per year in electricity. I mean, that's something else, isn't it? So Paul and Con, thanks very much for joining us. I appreciate we've come to 5 o'clock, but I think there's such a strong interest there. We'll just push on for maybe 10 minutes and try and cover off as many questions as we can, because there's been quite a few. So I'm going to hand over to Eoin, and he can run through those with Barry. Okay.
No bother. Thanks, Dónall. Okay, Barry, I'll start firing them at you if that's okay with you, and sure we can answer as many as we can, or the ones that are of most benefit. So the first one here that's catching my eye is there grant restrictions on leased buildings that you're aware of? You're just on mute there, Barry. Sorry.
Sorry. Yeah. So if you if you have the use of that building for a 5-year period, my understanding is that you don't need it. Now that's the way it will be in TAMS. I'm sure the horticultural grant aid scheme would be something similar.
Okay. Another one here. I am installing a 50 kilowatt system in the next 2 weeks. How long is the process with ESB to get registered to export excess electricity back to the grid? Well, that's the first part of that question.
Yeah, so it's an NC7 form that has to be sent into ESB networks, and as far as I'm aware, it's something like an 8-week turnaround by the time that you actually get approval to export back to the grid.
Okay. The rest of it's actually just a comment more that they won't be using electricity on the Sunday. So we'll keep going, I think. Actually, here's just one. Are the 50% grants for those under 35 available to horticultural companies where directors are all under 35? I'll answer that one. Just that the 50% grants are only available for sole traders under 35. They're not available to limited companies. So unfortunately, limited companies are only available for the usual 40%, up to 40%. So next one here, is there a better way to, or is it better to buy the equipment outright or do a deal with a provider that outlays the capital X or the capex, but has you tied into a long-term contract? I suppose it's a difficult one to answer, Barry, probably.
Yeah, look, that'd be dependent on what you're talking about there. I mean, I think that's one we take offline rather than discussing it here.
Okay. Yeah. Another one here is what is the current cost per kilowatt for industries or businesses? An average is fine. I know providers slightly vary. They're basing it off 21 cent per kilowatt. But I think they heard you mention 45 cent earlier in the talk. I think it has gone up very significantly. Isn't that right?
Yeah, well, I suppose the figure I mentioned for 45 was the import. If you have to import electricity or buy in electricity, you could be in certain situations, and depending on who your provider is, you could be paying a peak rate electricity 45 cents per kilowatt hour.
Okay. Yeah. I think some people were maybe on contract up until maybe last year as well, and it's gone up significantly since then as well, probably. Is maybe some of these, I think possibly you kind of covered, but they're important, so maybe just briefly go over them. What is the maximum size of solar panel I can install without having to apply for planning permission?
It's a 50 kilowatt system, which is 300 square meters.
Okay. Is it possible to install more solar kilowatts than I have maximum import capacity on the pole?
You could if you can use it yourself, but then again, if you are putting in a fairly big system, you may have to put in this thing called the G10 relay to make sure that you're giving security to the grid. So that could come in at an extra cost. So it's just something to be borne in mind if you are going above. And just to explain that your maximum import capacity, like 70% of people in rural areas would have an import capacity of 15 kVA, which maybe after the inverter might get them up to 18 kilowatts. So it's when you go into systems above this is where you're into that danger zone of, of requiring permitted allowances from ESB networks to go above that. And in some situations, it may require a G10 relay that may need to be installed.
Okay. Thanks very much. Sorry, I'll just go to the next one here. I'm a producer who has a 200 kilowatts of solar PV. During the summer months, I use all the electricity generated from the solar for cooling purposes. However, in periods in the year like March, April, and May, there is excess electricity being generated. Should I consider battery storage? And if so, do you know what size of battery I should get?
Yeah, well, look, again, that would have to be worked out on the individual farm itself. The battery storage, is that something, and maybe it's a question I put to you, Eoin or Dónall, is battery storage covered under the horticultural grant aid scheme, and are you limited by the kilowatt hours? Because in TAMS you are limited to 6 kilowatt hours.
I would say it is covered for own use. They're not being prescriptive about it, or not from the application side. There may be a follow-up requirement, but it's not something that I've seen. Eoin, maybe you've had a different experience, or?
No, I'd as far as I know, Dónall, I'd agree with that, I think.
Yeah, but in that situation, probably the battery storage, that's an example of where battery storage can make sense, but it's just to size it adequately. Is it 40 kilowatt hours? Is it 50 kilowatt hours of battery storage that would make sense? Each situation would need to be looked at individually. And I just don't want to pick a figure here and say you should go for this on this webinar.
No, that's fair enough, Barry, completely. Roughly, what is the efficiency of battery? If you put 1 kilowatt hour in, roughly what efficiency will you get out of it in a battery?
Generally, you won't get a full 1 kilowatt hour back, but you will get in the region of maybe 0.95, because it will not discharge fully. So it will only discharge practically the full 1 kilowatt hour will discharge back, but there has to be, for safety, it can't discharge fully.
Some of these may be, again, just let me know, Barry, if this is maybe better to be worked out. I'm considering investing in solar PV for my farm. How do I estimate how many kilowatts a 50 kilowatt system can generate?
Well, look at a 50 kilowatt system would be, yeah, it depends on the farm. Like a 50 kilowatt system, it won't generate 50,000 kilowatt hours. Like if you're down in Waterford, it might, or the sunny southeast, you might get close to, depending on the system, you might get 50,000 kilowatt hours for a 50 kilowatt system. But generally, it will be, you know, maybe 48,000, maybe 47,000 kilowatt hours you'd expect to be coming from a 50 kilowatt system. I suppose really what you need to examine is that'll generate the electricity during the daytime. Yeah, and we all know the peak hours when it's going to be doing that in the summer months as well. Will that be in line with your demand on your unit? And if not, you know, will you have to export excess electricity back to the grid? So you will be able to do that. Under 50 kilowatts is under the range of microgeneration. So you will be able to export back any excess electricity back to the grid in that situation. Now, as I said, the main issue at the minute is if you get a grant or a horticultural grant scheme aid, the ruling on it at the moment is that you can't get paid for excess electricity going back to the grid. And you do need to take that into consideration when sizing the system as well, that maybe if you're oversizing it at 50 kilowatts, there's no point. Each kilowatt is going to cost maybe an extra €1,200 to the overall capex costs of the system. So it's important that you size it to meet your demand.
Thanks, Barry. Pass over to Dónall. Dónall, do you have a question there?
Yeah, thanks, Eoin. Barry, a question came in before the event, and I know the person is on the line there, but it's about the potential for energy group schemes. So can people come together to form kind of a community? And I thought SEAI had some level of support for that. I'll just read out the specific question was, is there potential for energy group schemes, for example, community energy schemes that are established, managed and controlled by a defined local group that is defined by an area or numbers, like a group water scheme?
Yeah, I know what that's referring to there. It's the sustainable energy communities. So what they can do is in Ireland at the moment, there's what's called sustainable energy communities dotted all over the country. And some of them could be your local GA pitches and maybe residential situations all coming together, maybe getting the floodlights changed to LED, maybe getting the homes energy monitored. That they do, maybe getting a couple of farms energy monitored as well. But there are a couple of examples of agricultural SECs as well, or sustainable energy communities. There's one, a good example in Dingle Peninsula, whereby there's, I think there's 140 farmers in that particular group, and they've done energy monitoring. They've prepared an energy master plan for a number of those farms. So they've looked at different types of cooling systems on those farms. They've looked at the lighting that's been used on the farms, the heating the water as well, and they come up with optimized solutions for the farms in that area as well. So that's an example of an SEC, and they can get where they identify, I suppose, changes that can be made on those farms within the SEC. Then they can avail of what's called the Better Energy Community Fund and BEC. So there's a few acronyms thrown at you there. So you have sustainable energy communities, so that through an energy master plan funded by SEI can identify challenges within a sector and identify solutions to the problems, and that the Better Energy Community funding can kick in then to fund to meet those challenges.
Mm-hmm. Okay, so SEAI are probably the people who will help coordinate those meetings and develop a community program and assess how that can be done. Okay.
Yeah,
okay,
and it is possible, Dónall, as well, to get, for SEI, if the horticulture community were interested in getting some training or doing some energy monitoring, it is possible to do that. They have an SME section within small to medium enterprise section within SEI who will help in terms of energy monitoring and provide some supports there for the industry that could be maybe coordinated with yourselves in the horticultural unit as well.
Yeah. Okay. That's it's a good idea. Well, I'm going to just bring it to an end there for today. I really want to thank everyone who's joined us online, and we've had really great loads of questions coming in, lots of interest. Especially want to thank Barry for sharing his knowledge and experience there, and Paul Brophy and Contrast as well for coming online and chatting a little bit about their experiences as well. It's really appreciated, and having champions like that in the industry is very valuable for everyone. So thanks again. Our next event is going to be on the 7th of November, and it is looking at wind power. So I think again, it's a really topical area and maybe of more use to us than we've grown accustomed to with the solar. But I'll leave it there for today, and thanks again. And recording of this will be available up on YouTube in the next few days. Okay, so thanks again, and we'll see you all soon. Thank you.
Thanks, see you guys. Bye bye.
Thanks, Barry. Thanks, Donald. Thanks,
Bye-bye.
Paul and Con.